We'll be looking at engineering maths, okay, or some people call it calculus 4, okay. Looking at a series of topics, but we want to look at the separable equation, okay, um, at 0. So these are the format for differential separable equation. Your dy dx must be a functions of two variable, a function of x and a function of y. This is just a standard format for separable equation. So let's see some example. Uh, let's see some questions here. C said determine the following differential equation if it is what? Separable. Uh, okay, the first one, we have the y, the x equal to, here we have y squared times, this one we can break it down, times e 3x uh, times e to power 4y. So, and this will now give us y squared. You can bring the y together. Y squared e to power 4y and then e 3x. So this one is f of y and this one is f of x. So this is what? Separable. Uh, this is a separable. Okay, then the second one, it is, let's see if it's separable. We have the y, the x. This one, if we check it, you can factorize the x here. So you have 1 plus y all over y squared plus what? Plus 1. So this also is also separable. This is separable. So this is f of y, and this one is what? F of x. Yeah, separable. Okay. The third one here, not separable. It's not. It's not. Okay, because according to the standard rule, you must have what? F of x and g of y. So that's that on this question. For the standard formula, the y dx is equal to f of x g of y. Okay, that's the format. So what we can do here is to separate the variable, bring the y to come and join y here, and let the x go to the other side. Okay, so I'm going to divide both sides by what? By g of y. So that will become 1 over g of y dy equal to f of x. So multiply both sides by the x. So I have this. Okay, so that is how to solve that. Then the next thing to do is to take the integral of both sides. So that's how to solve separable differential equation. Okay, you separate the variable, let the y go to the y, and this one will go to the other side, and then you take the integral of both sides. Okay, so that is that on that. Let's see examples. Okay, so let's look at what we have on the screen. We have the y dx is equal to xy plus 3x minus y minus 3 all over xy minus 2x plus 4y minus 8. So the first thing we need to do for solution is for us to separate the variable. But before that, we can factorize this one. S is common there. Take x out. Then we have y plus 3. Here also, 1 is the common factor there. So that will be y plus 3 too. Okay. Then all over here also, factorize also. So that is what is common. S is common there. So that will be x over y minus 2. Okay. Then here 4 is common there. Take the 4 out. Then you have 4. Okay. And that will be y minus what? Y minus minus 2. Okay, so the dx will be equal to y plus 3 all over x minus 1. Okay, then all over here also, this one is the same, so you pick one of that. Okay, and that will be x plus 4. So that's what we have in this case. And you can see, if you want to join it together, you can see the f of x function, and you can see f of y function in this place. Okay. So I want to move this y plus 3 over y minus 2 to other side. And for me to do that, since this one is a fraction, I need to use the inverse of this fraction to multiply both sides so that it will cancel here. So and that will now become, the inverse is, just turn this one upside down. That will be y minus 2 over y plus 3 dy, dy. Okay, dy. And here I'm going to have x minus 1. This one is not going anywhere. X plus 4. Then multiply, your ds is there. Let it go to the other side. So that will be dx. So I've achieved to separate the variables. So that's what we have here. I'll try to repeat again. If you want to cancel this one from here, use the inverse of this fraction to multiply both sides. And the inverse of y plus 3 over y minus 2 will be y minus 2 over y plus 3. Use it to multiply both sides. So it will cancel on this side and it will be here. Okay, and this one is here, and then the x, let it go to the other side by cross multiply or by multiplying both sides by dx. Okay, so before we can continue here, if you look at this division, the degree, they are both linear division. The degree of this is 1, the degree of this is 1. So what we do is equal. So maybe you have to go to my video on a partial fraction where I gave the in-depth explanation on partial fraction. So in that case now, we divide this one. Okay, that will be equal to y minus 2 over y plus 3. Okay, so what do we do now? That will be 1, and that will be what? Y plus 3. Okay, so y minus y we cancel. Minus 2 minus plus 3. That's minus 5. That's minus 5. Okay, I'm going to do for this one also. Let's do for this one. The degree also is also equal. Okay, so I'm going to do polynomial division, and that will be x minus 1 over x plus 4. Okay, so times 1, so that will be x plus 4. So subtract, that will be minus 1 minus plus 4. That's minus 5 also. Okay, so I'm going to, this fraction is going to turn to partial fraction. This one also partial fraction. But before we go to partial fraction, we need to do this division, okay, because of the equal power of the numerator, because of the equal degree of the numerator and denominator. Okay, so for the left hand side, I'm having now y minus 2 over y plus 3 is equal to the quotient 1 minus 5 over y plus 3. Okay, so that's that. Yes, I've done that. So the y equal to the right hand side, that will also be 1 minus 5 all over x plus 4 dx. Okay, so then we can introduce our integral function. Okay, so that will be equal to integral of sum of functions or difference of function will be integral of each of those functions. So this will be y, integral of dy, this one times this one, dy, that's y, then minus integral of this one. This one is 5 in the brackets 1 over 1 plus 3 dy equal to this one also, that will be x minus 5 integral 1 over x plus 4 dx. So final, we have 5 minus 1 over 1 plus 3. Okay, this is advanced class, but I'll still try to explain it. The derivative of it's just like how the figure of 1 over x is what is ln x. Okay, so if you are not adding any constant here, it doesn't change the format of the integration. It just be equal to x plus 5. Okay, that's what you are doing. So in this case now, this will be equal to y. This is equal to y minus 5 ln y plus 3. Okay, equal to x minus 5 ln x plus 4. Okay, plus c. Then you add your constant of the integration to the right hand side. So that's that on this equation. That's that on that equation. So the only thing that we just did here is just this division of the equal degree. Then we just use the polynomial division. So and we have done that. So there's no need to continue with the partial fraction. Just do your polynomial division for this one and for this one, which we have done. Okay. So let's take another questions. Let's take another question. Question 2. Question 2. Solve dy dx equal to x times ln 2 ln x plus 1 all over sine y plus y cos y. So that's what we have there for the second question. So let's see what we can do here. We have x into that. So can we? This is okay. This is separable function. So this is function of y. This function of x. Okay. So can we cross multiply? So that will be sine y plus y cos y. Okay, dy. Okay, equal to x brackets 2 ln x plus 1. Close it. 2 ln 2x 2 ln x plus 1, then your dx. Okay, let's go multiply. Since it's separable, this is a function of f of x, this is f of y. You can go this way, this one can go that way. Okay, so then the next thing to do, introduce your integral functions. Introduce your integral function. So we are going to this one mean this will be integral of sine y dy plus integral of y cos y dy. So let's solve the left hand side first. Now let's solve the left hand side first. If you integrate this one, that will be minus cos. This one will be minus what? This will be minus cos y. Okay, but this one, that's where the problem is. I'm going to take it out. Integral of y cos y dy. So this is a product. This is one function y. This is cos y. So we're going to use integration by parts. Okay. So my u is y, and my dv is equal to cos y. Okay, cos y dy. Okay. So the u is equal to what? Dy. The u is equal to dy. Okay, and this one, integrate it. If you integrate this one, integrate the v, that will be v, and integrate cos x, that's sine, cos y, integral of cos y, that's sine y. So we've gotten our uv. Integration by part, I'm using this formula uv minus integral of v du. That's what I'm using in this case. So my u is y, my v is what? Sine y, okay, minus integral of v is sine y, and then my du is the y, okay. So, and this will give me y sine y minus integral of this one of sine y is minus cos y. So minus minus is become plus. So I've done that. So the left hand side now, I'm now having for the left hand side, I'm having the integral of this of sine y as minus cos y. Then integral of these products, that is equal to plus y sine y plus cos y. So the right hand side is done. Right hand side is done. So, and with that, this one on the left hand side, this one and this one will cancel out. So on the left hand side, I'm only left with y sine y. I'm left with that on the left hand side. Okay, let's now go to the right hand side also and see what we can get there. Let's get to the right hand side and see what we can get. For the right hand side, we also have two items. We have sine and we have x plus 1. You can see 2 in x plus 1. So bracket open here and bracket close here. Okay. So so integral of x times x ln x plus 1. So let's call this is also a product. This is one function, this is another one multiplied to this x times 2 ln x plus 1. So this will be easy for us to differentiate u 2 ln ln plus 1. It's much easier to differentiate. So can we get the differential of that? So the u of this one, if we differentiate the one, the u will go to what? Actually, if you differentiate ln x, that's 1 over x, okay? So that's 1 over x times 2. That's 2 over x, okay? Then the v is what? Is x, okay? The v is what? Is x. The v is x. So v is equal to what? S squared over 2. I know you know how to integrate. The formula for integration, we have xn. The integral will be equal to what? N plus 1 all over the power here. N over what? N over n plus 1. So that's how to integrate. That's how to integrate. Okay. Well, actually, this advanced class, where you've been taught calculus 1, calculus 2, and my video also, I think there are a series of lectures on calculus and integration. You can also check that one out. Okay, here, so that'll be the u dx with respect to x. Okay. So let's substitute uv. I'm using uv minus v integral of v du to the right hand side. My u is this one, my v is this one, so that will be equal to 2 times this one, that's uv, that will be s2 over 2 times 2 ln x plus 1 as my uv, then minus v, integral of v, my v is s2 over 2. The u is what? The u is 2 over x dx. That's my du. Okay, so here s, one we cancel here to remain 1 here, 2 we cancel here, so I only have x dx in this place. Okay, and this one is what? S squared over 2 into bracket 2 ln x plus 1. Okay, so that's that on that. Then we can quickly make a final conclusion now. We have the left hand side. Our left hand side is y sine y equal to the right hand side. We have this one, s squared over 2 into bracket 2 ln x plus 1, okay, and then minus integral of x, that will be, is having power 1, so that will be s squared over 2, okay, and then plus c. So that's that on that question. That's that on that question. If you integrate x, it's having 1, so that will be plus 1, that's 2 over 2 again. So that's that. Follow this formula for general integration. So this that on this question. We'll still continue on the separable equation. Okay.